I'd like to share with you the design of an application that can automate the research of just about any topic. The design we will be building and analyzing in this video revolves around several AI agents that will, 1, ingest data from multiple sources at a configurable interval, for example, once a day or once a week. 2, will filter the data for the most relevant parts based on our needs. And 3, present the final results to us in a digestible format, conveniently delivered by email. This design pattern is highly versatile and can be easily adapted to a wide variety of use cases, but for demonstration purposes, we will be building a team of agents that will update us daily on the latest developments in the realm of applied AI and social media marketing automation. Here is a diagram of what we will be building. In the sections ahead, we will implement this design from scratch, ensuring you gain a deep understanding of how to use and adapt it to your needs, with the benefits including A, mental clarity, B, save time, and a result of A and B, competitive advantages, baby. As for costs, assuming you already have a computer, the cost of implementing this design will be under $1 to get started. However, ongoing costs will depend on the amount of data being processed and the frequency with which you run the agents. For example, if you run the agents once a day, that's going to cost more money than running them once a month. And finally, before we get started, I've included a boilerplate project to make it as easy as possible for you to implement this design pattern for yourself and for your team moving forward. If you're super advanced and familiar with all of these concepts, you'll probably just want to clone that boilerplate repository and be on your way. But for those who are here to learn and are here for the walkthrough, I will see you in part 1. Here we are, starting with an empty folder somewhere on our computer. You can see it's empty. The folder I'm going to be using is called Research Agents. You can call yours whatever you want. I'm going to be programming on a MacBook Pro. If you're using a Windows or Linux machine, the exact steps of what you'll see me do will be a little bit different for you, but the high-level overview will still be the same, so don't worry about it. And with a Mac operating system comes this application called Terminal that allows us to interact with our computer, much in the same way that we would use our mouse and keyboard to interact with the graphical user interface. This Terminal application also lets us interact with our computer. You can use whatever the corresponding terminal or console application is for Windows or Linux. But anyways, if your machine is not exactly set up like mine, you should be able to still grasp the high-level overview of what we're doing here. So here I'm going to use the terminal to go into the Research Agents folder and then open it with my code editor of choice. You can use whatever code editor you prefer. Use whatever's comfortable for you. It doesn't matter. You'll still be able to follow along. Okay, this is VSCode. For those who don't know, it's a very common application for building programs. It's free. It's simple. It's not the latest and greatest code editor, but it'll do the job. So it's very similar to other code editors. It has a very similar layout. Here you have a pane that allows you to view all of the files and folders within your project folder. If you click on one of the files here, this pane will allow you to edit the code inside of that file. And it'll color all of the code in a way that makes it easier for you to read it. And you can see here, there's a section with a bunch of different tabs that are going to be useful in different scenarios. We're definitely going to be using this one, which is a terminal just like the one we just used. And as we build this application, we're going to be issuing commands to our computer through this terminal instead of the one that sits outside of VSCode. So this is just a little productivity hack. All right, now let's start to pick up steam. So in order to follow along, you're going to need a computer, You're going to need a code editor like VSCode, for example, and you're also going to need Python installed onto whatever machine you're using. Here you can see I'm using Python version 3.12.8. Later on, we're going to be using a tool called CrewAI, and CrewAI requires a version of Python between 3.10 and 3.13 in order to work. That's the rationale of why we're using this exact version. At the time of recording, the latest version of Python is 3.13, I believe, so this is pretty much the latest version of Python. The next thing that we're going to do is create our virtual environment. So the term virtual environment sounds very nerdy. It's actually quite simple. All that means is we are setting up Python on our machine to install any third-party Python packages that we use when we're building this application into this .vm folder that we just created right here. When you build Python applications or any application, it's nice if you can reuse code that's sitting out there on the internet. And Python has this system or this platform called PyPI, P-Y-P-I, PyPI, Python Package Index, that allows you to download pre-written libraries of Python code so you don't have to write them yourself. After we create this .vm folder, we activate our virtual environment by entering this command. And if it works, you should see your terminal prompt change a bit, right? and that'll let you know that this worked. So now that we have our virtual environment set up, let's download our first Python package called UV. UV is a tool that allows us to download packages from PyPI faster. It's an amazing tool. It also does other things, as you'll see, but that's why we like to use UV. So it's like 10 times faster than the next best tool. I said UV is capable of doing several things. So this is another UV command. As you can see, this one will scaffold out a simple project for us, right? And it created this hello.py file that we can quickly test to make sure everything is working. And yep, you can see we are printing out this text right here. Let's delete this hello.py because we're not going to need it. And let's move on. Okay, so the next thing we're going to do is scaffold out all of the folders we'll be using to organize all of the code we will write. So an analogy of what we're doing here is we're planting a Christmas tree. Bear with me. And after we plant the Christmas tree, we're going to decorate the Christmas tree with ornaments. So in this analogy, the folders that we're about to create are the Christmas tree. And moving forward, we're going to add files and subfolders within these folders. And that's sort of like decorating a Christmas tree with ornaments. So from an analogy standpoint, that's literally what we're doing. Let's start creating these folders. I hope the names of them are very intuitive. This is the folder where we're going to hold some of our configuration. In programming, you have this concept of a bit of code that is very helpful. Hence, you call it a helper function. Any helper functions that we want to include will be stored there. The prompts that we write will be stored here. And the next folder we will create is called Pydantic types. So Pydantic is a tool that allows us to validate data. So there's going to be certain points in our application where we're going to expect certain types of data, and Pydantic will allow us to easily see if the data that's coming to us is as we expect or not. The next folder is the test folder, which we're not actually going to use, but on principle, it should be there. And the next folder we'll create is the tools folder. So in the concept of AI agents, you need to give them tools in order for them to do anything meaningful. So the best analogy I can think of on the spot is that of Mr. Freeze. So Mr. Freeze is this character in Batman. He's a villain, but he's this character that only has a head. He doesn't have a body. So he's very intelligent. He's able to speak, but on his own, he can't really do much. He needs a body that he can control in order to do anything. He needs to be attached to these different types of robotic systems in order to actually move around the world and affect the world. So that's the same way that AI agents or LLM agents work. So they're capable of receiving text and spitting out text, but in order to affect anything beyond that, you need to give them what are called tools, which, as you can see, are not that complicated. They're really just Python functions. It's very simple, as you'll soon see. And the last folder that we are going to create is called the scripts folder. And here's where we'll place any utility scripts that will save us time. So that is the Christmas tree. Now let's move on to decorating this Christmas tree, aka adding all of the files. Okay, so inside of the config folder, we're going to add 2 files. And I hope the names of these files are intuitive: agents.yml and tasks.yml. Inside of the helpers folder, we're going to add 4 files. And I hope the names of these files are intuitive: execute task async, format news for email, is valid email, send email with SES. SES is the email provider that we're going to be using. In the prompts folder, we're going to add 2 files: analyst task description and research task description. In the Pydantic types folder, we're going to add 1 file. Let me close these. The scripts folder, we're going to not worry about for now. We're going to add some scripts, but we'll add those later. In the tools folder, let's add 2 files: scrape website and URL quality assurance. These will make sense later. The last file we're going to add for now is our entry point. when we run the main.py file, it in essence runs our application. Okay, so now in the same order that we created these files, let's go through and add code. Here is the code that we will paste into the agents.yml. Let's get a quick overview of this. Hopefully this is intuitive. Here is where we're putting some of the configuration regarding our agents. So in our application, we're going to have a researcher agent and an analyst agent. And in CrewAI's framework, if you want to call it that, the way you define an agent is by giving it a role, a goal, and a backstory. The next code we're going to add is the code for the tasks.yml. Hopefully this is intuitive. We're going to have multiple sources of data. Pretty much what each agent is going to do on each source of data is extract the 8 most relevant points from it regarding what we're interested in. And at the end of the day, the analyst agent is going to review all of the research that's been done and output a list of the 5 most important items regarding what we're most interested in. The next file that we are going to add the code for is the execute task async function. This will make sense later. The next file is the format news for email function. Let me close the terminal quickly so we can get an overview of what's going on here. Pretty much what this does is convert the news or information that the final analyst agent has identified as being most important into a easily readable email. Next file is the isValid email. Hopefully this is pretty straightforward. And the last helper is the send email SES function. This allows us to send a formatted email to whatever destination we'd like. Here are the prompts that we'll be using. We can adjust these if they don't meet our needs very easily. I'll let you take a gander at this. It's pretty general purpose. Like I said, if it doesn't meet your needs, you can easily tweak it. And here is the prompt for the research task. Pretty general purpose as well. If it doesn't meet your needs, you can easily tweak it. This is the next file that we're going to add the code for. We are soon going to import a number of libraries from PyPI and it'll fix these import errors. So disregard this for now. Here you can see that we're asking the agents to return to us news, and we are using Pydantic to make sure that the news is returned to us in this very specific format. That's why we are using Pydantic, or that's how we are using Pydantic. The next thing is the tools. All right, disregard the import errors. This is a tool that allows our agents to download information from websites on the internet. The next tool is the URL QA tool. This is a quality assurance step to make sure that any links that the LLM decides is a valid source is actually a working link. And finally, we are going to add this code to the main.py file. Ignore the import errors and let's collapse some of the sections so that we can get an overview of what's going on here. I think that fits, right? All right, so this is just imports, right? This is some code that's useful if you want to do breakpoint debugging. If you don't know what breakpoint debugging is, it's the ability to pause a program, right, as it's running. We're not going to be using this in this video, but I included this here because sometimes it's useful to do this in order to figure out what's going wrong with an application. This is a monitoring tool called AgentOps. This is related to testing our application. We're not going to use this. Like I said, we're not going to focus on testing. And here you can see we're retrieving the current date and importing all of the configuration from the agents.yml and task.yml. Importing a mailing list. This is a list of emails that our agents are going to report information to. And here is the meat of the matter. So as you can see, this research agents application is quite simple. So we have 2 agents. After we create our agents, we create the tasks that we're going to assign to our agents. All of the research will be performed in parallel. That's what's going on here. So we're creating 3 tasks that we're going to give to the research agent. Pretty much what's happening here is we're having the research agent read a bunch of websites for us in parallel. And after all of that research is finished, we pass all of that research to the analyst agent. And the analyst agent will give us our final filtered information according to our needs, and will deliver that to us in a nicely formatted email here. Quite simple. So this is the majority of the code related to this application. So I hope you have an overview of what it's doing. It's not that complicated. Let's move on. Let's close all of these files and collapse all of the folders just for peace of mind. And then let's pop open the terminal again and install all of the PyPI packages that we will be using. Super fast. Clear this. And now when we look at our files, we should see those import errors go away, I think. Yep, you see the import errors have gone away. Okay, so we're almost ready to run this application. All that we have to do is provide environment variables. When you're building an application, oftentimes there are some sensitive pieces of data that you need to give to your application in order for it to run. But for security reasons, we prefer to not store these sensitive pieces of information in the code itself. So the typical technique is to create a file where you hold all of these secrets, and you'll usually see this file called .env. So for our application, you're only going to have 6 secrets or 6 environment variables. I'm not going to show you what they are. That's the whole point. So you'll have to generate your own versions of these secrets yourself in order for the application to work. Here you can see we're going to add in an OpenAI API key. Same thing with the AgentOps API key. I don't want you to have a copy of that. As far as the mailing list, I want that to be easily configurable. This is not the best way to make it easily configurable, but it's better than hard coding it inside of the application. And also, I don't want anybody to know who's receiving the updates from this application, right? I want to keep that private. So, and finally, these 3 secrets are related to authenticating to AWS SES. So SES is the email provider we're going to use. So we're not building the system for delivering emails. We're going to reuse AWS's. Okay, so I've added the environment variables and we're ready to give this thing a spin. We're using GPT-4o, as you can see here. You can easily configure what LLM the agent uses via this field on the agent class, but we're going to keep it simple. Let's just use plain Jane old GPT-4o. So the way we run our application is by entering this command, uvrun main.py. Let's run this and see what happens. Let's expand this. A lot of information. All right, so we did all the research. Now the analyst is reviewing all of the research. It's picking out the most important parts. It's verifying the sources. It's making sure all the sources have working links. And it sent an email to us. So if we come over to our email, this is what the report looks like. All right, let's wrap up part 1. And because I'm going to be sharing this code with you, I want to make sure that a few of the files that are in this project are not shared. For example, the .env file. So we can add this special .gitignore file to ignore certain files in our project. I'll also ignore this one. And yeah, we're not going to cover Git in this video. That's a whole different topic, but Git is a tool for sharing code and collaborating with others. So anyways, now that we have that set up, let's move to part 2. Welcome to part 2. In part 2, we are going to ship our agents to the cloud. In order to do that, we're going to use a tool called Docker. This isn't a deep dive on Docker, so I'm pretty much just going to show you how this goes, not explain too much. If you have questions about Docker, leave a comment, and there's plenty of resources where you can learn more. So what I'm doing here is launching Docker. You'll see this little whale icon in the top nav bar after I launch Docker. And when it boots up, we can then start using it. So first I'm going to add a Dockerfile, and here's the content of what we'll paste into this Dockerfile. What this is doing is packing all of these files and folders in our project into this standard format called a Docker container. And the nice thing about a Docker container is that if it runs on our machine, it can run on any other machine that also supports Docker or also has Docker running on it. Next thing we'll do is add a dockerignore. And these are the files that we are going to ignore. In the same way that the .gitignore ignores files when we upload code to GitHub, the dockerignore ignores files and folders when being packed into the Docker container. So whatever files and folders we list here will not make it into that Docker container. And next up, we're going to add a Docker Compose. This is the content that we'll paste into this Docker Compose. And now that we have that all set up, we can run our application as a Docker container. Great, so that worked. So we tested our application when being packed into a Docker container, and it worked as expected. It worked the same exact way as when we tested it directly on our machine. And now that we have our application packed up into a Docker container, we can not only run it on our machine, but we can also send it to other machines on the internet and run it there. So there are many systems that support Docker containers. The one that we're going to use now is called Cloud Run. It's a service offered by GCP, aka Google. This is not a deep dive on Google, so I'm pretty much just going to show you how this goes. The way I'm going to interact with Google is via a CLI tool called gcloud. This is the version of the gcloud CLI that I'm using. And I have to log into GCP. And if I paste this URL into my browser, I'm doing this on my other monitor. After I log in, it should print a message saying that I'm logged in. And yeah, you can see, right? I am logged in. Fantastic. So now that we're logged in, let's move forward. And here are some variables that we're going to set in our terminal. If you've never done terminal programming before, you can set variables. And these are the first batch of variables that we'll set as we send our container off into the cloud, aka to Google Cloud Run. So here we go. First, what we're going to do is create what's called a repository. A repository is a place where we can store Docker images. When you run a Docker image, you get a container. I'm not going to go super in depth on Docker. Like I said, I'm just going to go through the process of what this looks like. Here is the Google dashboard that allows you to see which artifact repositories you've created. I've created quite a few. The one we just created is this one, Research Agents Repo. The repository is a place where we can store images, as I was saying. So next up, we're going to configure Docker to be able to upload images to this repository we just created. And now let's build our project into an image. And now that the image has been built, let's upload it to the artifact repository that we just created. All right, so that finished uploading. And if we reload the Google dashboard, you can see we now have our image or our container. I'm just going to call this a container or image interchangeably. Technically, there are different terms, but like I said, I'm not going to dive deep on Docker. So we have our container here, and now we can run it. Here is how we run our container in Google Cloud Run or GCP or Google. I'm using a lot of these terms interchangeably, but like I said, just focus on the overall process. So what we're doing here is we're running the container in the cloud. We were running it before on our machine. Now we've sent it to the cloud, and now we're going to run it in the cloud. So all it takes is these next two commands, right? It has been successfully deployed. If we come back over to the jobs tab. So the difference between services and jobs is services are applications that are intended to run a long time. Like for example, a web server. A job is something that you run, it stops, and then it shuts down. If you want to trigger it again, you have to run it again. It'll run, then it'll shut down. So for what we're doing here with these agents, jobs is more appropriate. So here you can see research agents. And if we trigger this job, it's going to pull in our image and run it. And when we run an image, we get a container. Let's see what that looks like. So I said it was only 2 commands that are needed to run this container. Here's the second one. Come back to the console, refresh it. Right, you can see our job is in the process of running, or our container is in the process of running. So a lot of synonyms here. Anyways, focus on the high level. Come back to the details later. Right, and now you can see it's running. If we click on this job, come over to the logs. Fantastic. So this is actually expected. You can see we're getting a bunch of errors, and this is because we didn't do that step where we needed to add the environment variables. So in the next sequence of commands, what we're going to do is add the environment variables that our application needs into Google. And it looks a little bit weird, but it's really the same exact thing. So the same way that we added that .m file when we were running our application on our local machine, we're going to upload our secrets or our environment variables to Google Secrets Manager, right? So it's the same thing, it's just branded differently. And let's quickly look at what that looks like. I mentioned in part 1, we were going to be creating some scripts, and now the time has come. The first script we will create will be this upload secrets.sh script. Here is the code. And what this is going to do is read all of the secrets in the .m file and upload them to Secrets Manager in Google. So this is a technical thing that you have to do. Pretty much what we're doing here is telling our computer that we're giving it permission to run this script, this .sh script. And now you can run it. And you can see here, we're going to prefix each secret in our .m file with this research agents prefix. So when we look in Secrets Manager, after this is finished, we should see some new entries that say research agents. So let's run it and see what happens. Fantastic. So we had 32 secrets before. We refresh, we now have 38, right? And we see some entries that are prefixed with the text research agents. Great, that worked. So now what we do is reference these Google secrets in our Cloud Run job. We're going to use another script to help us do this. Us doing this manually is quite tedious. Yeah, we're going to create another script called build set secret string. And here is the code that we will add. And what this is doing is building a really long string that concatenates all of the secret IDs in Google Secrets Manager for us so that we can paste it where we need to. And you'll see what this means. This is a very handy script. So We have to do the same jazz. Make that executable. And run this thing. There we go. So we can copy this and then paste it into the Google run jobs deploy command. And let me show you what I mean. So we're going to redeploy our container, but this time we're going to let Google know where our secrets are. And that build set secret string.sh script is what helped us with this part. Manually typing this out is very annoying. So if we run this and then run our agents, let's see what happens. So let's come back over to our Cloud Run service. We can see they're running. Click into them, go to the logs, and there we go. So yeah, you can see we got another email sent to us. So it's working. Okay, so the way we run these agents on an interval in the cloud is by using another service in GCP suite called Cloud Scheduler. So here I'm setting a few more environment variables that we will use in the subsequent command. Here is the command we enter to create a scheduler. So this is where we are able to configure the interval. So this is an expression which means once per hour. We can easily tweak this to be once per minute, once per month, twice per month, every Monday, Wednesday, Friday. It's very flexible as far as what you can do with this expression. So anyways, let's enter this. And if we come back to GCP, let's come over to Cloud Scheduler. And here is the scheduler that we just created. You can see it hasn't run yet. Great. So pretty much what this is doing now is triggering our agents to send us a report every hour. Fantastic. For the final section of this video, part 3, let's set up a quick CICD pipeline to automate all the steps we performed manually in part 2. Software needs to update and change quickly. So each time you want to update our agents, it would be nonsensical to manually do part 2 over and over again for each update. So let's automate part 2 and part 3. See you there. Alrighty, let's wrap this baby up with a bow tie. So we are going to create our third and final script called generate service account.sh. Let's do this jazz of making it executable. And here is the code that we will paste into this file. So this is going to generate a service account for us that we can then give to GitHub, and GitHub will then have the necessary permissions to be able to automate all of the things that we did in part 2. So let me shut up and just show you how it works. So let's run this. And if this works, we should have a JSON file that contains all of the credentials for this service account. A service account is a fancy name for a username and password that we don't use as a human, but that we give to some application or to some computer to use on our behalf. So in this scenario, we're giving the service account to GitHub. And it looked like that worked. And here you can see that we have the JSON I was mentioning. So now let's copy this JSON to GitHub. And if I come over to GitHub, create a new repository for all this code, and we're going to call it Research Agents Social Media Marketing Automation. Create this, and then come over to the settings, and let's add a new secret called GCP Service Account Key. And you're going to copy the contents of this file into that field. All right. We'll add the secret. Bingo. So the next thing that we need to do is create a GitHub action. And the way that we do that is by creating a special folder in our project called .github. And inside of that .github folder, creating another folder called workflows. And inside of here, we can create a file that can be called whatever we like. I'm going to call mine CICD.yml. And here is the content that we will paste into this CICD.yml file. So I'll let you read through this. Pretty much we're automating what we did in step 2. Right? I'll collapse it so you can see an overview of what's going on. All right, so one quick thing, we don't want this to be uploaded, so let's ignore it as well. This is the service account. We're also going to ignore a bunch of other files and folders. So I'm adding a bunch of other entries into the .gitignore as well. There's a ton of files in here that we don't need. Doesn't look like it, but it's true. You see this PyCache, for example, we don't need that. There's a number of files that we don't need. So perfect. Initial commit. Now let's push. So now you can see we have an automation in flight. And that worked. Holy moly. Okay, now that we have all that set up, let's make a quick little change and actually use our agents. And what I'm going to do is come over to the research task and have clear relevance to applied AI and social media marketing automation. Yep. All right, so we have all that saved. And let's update the prompt for researchers. And then push. If we reload this, we should see another automation in flight. So as soon as this is done, we will manually trigger our agents and not wait for the next trigger from the scheduler. Trigger our agents. Come over to the logs. And you can see the output is a little bit more related to social media. We could tweak the prompt a little bit more until we get what we want, but now you have an understanding of how the system works and enjoy the benefits that it will provide to your life. Peace. I'm gay. Yes. Respect.